Okay, last homework of the unit, Unit 7. Talking about extreme values, so overall maxes and mins, as well as average values. This will help us complete all of those free response questions that we were asked that we need to be ready to do for our test. First question is, explain the extreme value theorem and why does it care so much about endpoints? So overall maxes could be at locations of relative maxes or mins. So let's say I have a function like this. So this location could be at relative max mins. If we're talking about, a function starting here, ending here, this would be the location of the min, overall min, the absolute min. But this endpoint is the location of the absolute max. So the important part is that it's not necessarily absolute mins at a relative min. The absolute min or absolute max could be at an endpoint. The key is you'll have to check. And we'll talk about how, depending on the situation, you won't always need to check out endpoints. No. Say you're finding the max v, and v prime is this, with 1, 0. You know without a doubt that this must be the location of an absolute max. Because if v prime is positive then negative, v is going to be going up then going down. So doing a sign analysis can help you eliminate what we can say is potential candidates. So that has to be the absolute min. Now, absolute max right here at this location. Now, the absolute min could be at either of the endpoints. It will be at an endpoint in this situation. This is just one situation. Understanding that I can do a numerous amount of situations. Just an example of like I don't have to check the endpoints because I know v prime is just positive and negative. That has to be the max. V is going to be increasing and decreasing. All right, so I'm giving you some position functions. I'm asking you when the particle is furthest to the right or to the left. So furthest right would be a max position. Furthest left would be a min position. So I want to find the max and min of position. So you're going to take the derivative of position to see when is my position increasing or when am I going to the right versus going to the left. And more importantly, when am I changing directions? Because that could be a possible location where we'll have a max or min. So I got 3. I'm checking it between 1 and 4. Here's my velocity, which is x prime. I will plug in values. I see negatives until 3, positives until 4. I know for a fact that t equals 3 will be the absolute min, or furthest left. Don't need to find the location, don't need to check. I know for a fact I'm moving to the left. Stop, moving to the right. I must be furthest left here, okay? Or my position is decreasing, then increasing. I must be the furthest, my minimum position must be here. Now the absolute max, or when I'm furthest right, has to be either at x of 1 or x of 4. And this is where we're going to have to check. I'm going to have to plug in 1. I get 1 minus 6 plus 2, which is negative 3. And I plug in 4, and I get 16 minus 24, which is negative 8, plus 2, negative 6. So t equals 4 wins. I'm going to use my calculator just to double check some of these values. 1 minus 6 plus 2. 16 minus 24 plus 2. Okay, great. All right, furthest right, furthest left. I'll find my velocity or see when my position will change from increasing to decreasing. We got 3t squared minus 4. Great. I will add 4 divided by 3. Take the square root. And I get square root of the top is 2. The square root of the bottom is root 3. And that gives me plus or minus. I won't need to worry about the minus because I'm talking about an interval from 0 to 3. The only value that's between 0 and 3 is the positive 2 over root 3. I'm not going to rationalize that. Now let's see, if I plug in something like, 2 or 1, that's bigger than or less than 2 over root 3. This is 2 divided by like 1.7, I think. So it's a little bit bigger than 1. So I plug in 2. It's positive. If I plug in 1, that's a negative. So once again, this is the location of our absolute min. I'm going to be furthest left. To check where I have particle furthest right, it's either going to be at the endpoint 0, which will give me a position of 0, or the endpoint 3, which will be 27 minus 12, which is 15. So furthest right will be at position 3. Now I don't want us to think that it will always be this right endpoint. It could be the left endpoint. Just these first 2 examples might have been like that. Okay, let's keep going. See when I'm traveling to the right, traveling to the left. See when my position is increasing versus position decreasing. 3t squared minus 12t. I'll set that equal to 0. 3t. T minus 4. I got 0 and 4. I'm looking between 0 and 5. So 0 is important. 4, 5. Plug in 4.5. Positive, positive. Plug in 3. Positive, negative. So same deal here. Left will be at t equals 4. Right will be either at x of 0 or x of 5. I'm assuming it's going to be at 5. Actually, it's not. 5 cubed minus 6 times 5 squared. Negative 25. Oh, yeah, it is furthest right. Oh, yeah, okay, good. Furthest right would be at the largest position. This will be at 0. So t equals 0 is furthest right. So here's the other endpoint. Hopefully this one will change signs multiple times. We'll have to check. We won't have a definitive answer for anything. So x prime, which is v, is t squared minus 6t plus 8. Okay. Set that equal to 0. I got negative 4, negative 2. So I get 2 and 4. I'm looking between 0 and 5. And this is a great example here, because after the sign analysis, you realize your position is increasing, then decreasing, then increasing. So this is the location of a relative max, but the max, when I'm furthest right, could be at 2 or at 5. I know that because I'm going to the right, then to the left, but then I end up by going to the right. So this is where candidates are required for both situations. The min, when I'm furthest to the left, would be at 0, because I'm going to the right after 0, but then at 4, where I have a min position here, x of 4. So x of 0 or x of 4. So I end up having to check all of these values. Now, to do this quickly, let's pretend we do have our calculator. I'm going to graph 1/3 t cubed minus 3t squared plus 8t. And I'll plug in 0, 4, and 2, 5, 0, and 4 by using trace. So 0 obviously is 0. That's good. 2 is 6 2/3. 4 is 5 1/3. And 5 is going to be the biggest. Oh, it's 6 2/3 as well. Okay, notice that these values are less than the values that we know they're below. Like I know 0 is going to be less than 2. I know 2 will be greater than 4 because I'm decreasing from 2 to 4. So by comparison of all of these, we could see that at t equals 0, this is our min, or this is when we're furthest left. And then I see at both 2 and 5, I have 2 maxes. When t is 2 and 5, I'll have the position that's furthest to the right. Okay, using the same position functions from above, find when the velocity is at a max or min. When is the particle traveling fastest to the right or fastest to the left? Okay, so now let's think about finding max or min velocities. How do you find a max or a min or something? You take the derivative, set it equal to 0, and you check your endpoints. So it's important. We get velocity by taking the derivative of position. But then you need to take the derivative again to get v prime. I get v prime is 2. Now, what does that mean? From 1 to 4, v prime values, or my acceleration values, are always positive. They're always positive 2. That means, for a fact, I know that this location must be the location of a min. I mean, this is telling me that v is going up, so the velocity values are increasing. So that must be the min, because I start here, I go up, and then I end here. My velocity derivatives is positive. That means velocity is going up. So this must be the max. So I don't have to do some checking. I know that t equals 1 must be the min velocity, and t equals 4 must be the max velocity. Okay, same deal. Find the max velocity. Well, let's find velocity function by taking the derivative. I get 3t squared minus 4. Then its derivative, it should be a square, but whatever. V prime would be 6t. I'll see that change of sign at 0. That won't really matter because my interval is from 0 to 3. So I'll have another situation where this is the location of my min, and this will be the location of my max. Okay, next one. Velocity, 3t squared minus 12t. Its derivative, 6t minus 12. Its derivative will change sign at 2. I'm looking from 0 to 5. This is v prime. It's telling me if v is going up or down, increasing or decreasing. Plug in 1 negatives, plug in 3 positives. So v is going down and up. I know this is the location of the min. So t equals 2 is the min velocity. For the max velocity, I need to compare my candidates of v of 0 and v of 5. V of 0 is negative 12. V of 5, 6 times 5 is 30, minus 12 is 18. So definitely my max velocity is at t equals 5. Okay, and then this guy, the velocity t squared minus 6t plus 8, the derivative of velocity 2t minus 6, we're looking at 3, 0, 5, 3. Just so happens we got positives and negatives there. All these end up being like this just because of the way the position was looked at. If there are differing signs, the signs would change. Just so happens that it'll be like this. Please don't assume that the signs are going to be like that. Always check your signs. So this is V prime. That's telling me V is going down and going up. So I know this is going to be a min velocity. My max is either at V of 0 or V of 5. Make sure you know that you're comparing values of velocities. V of 0 is negative 6. V of 5 is 4. So very similar problems, kind of these two and these two. Okay, that's a good question. I'm giving you the graph of velocity. When is the particle furthest to the right? What is the position given x of 0 equals 2? Okay, so like you can see my velocity graphs. Now think about that. This is the derivative of position. When I ask you furthest to the right, it's not like when my velocity is max. It's when is my position is a max. Okay? So when is my position a max? That will be when its derivative possibly changes sign or at an endpoint. So immediately I'm going to just go ahead and say, like, let's look at the signs of x prime, which are V. They are positive until 3. They are negative till 5. And they are positive until 6. Okay? So that's telling me my position, or since you can look at the velocities, I'm going to the right, and I'm going to the left, and I'm going back to the right. I immediately can say, okay, my possible maxes when I'm furthest right are at 3 and 6. But then the question becomes like, how can I find x of 3? And how the heck can I find x of 6? Well, this goes back to what we could do from last class, where an unknown equals a known plus a displacement. We know displacement is the area under my velocity curve, or the area under the derivative of position. I could literally do this. Sorry, this would be 0 to 6. And the areas under my velocity, which will tell me the displacements, will give me the answers that I'm looking for. So like this value of 5, that means my displacement is 5, or I move to the right 5. This area of negative 3, that's a displacement of negative 3. That means I move to the left 3. So I started at 2, I went to the right 5, I went to the left 3, then I went to the right 1. You could have literally been able to interpret that and then answered your question by just looking at some values. And here is where I went to the right 1. This is kind of what that's saying. Starting at a position of 2, add a displacement of 5, and I get a position of 3 at 7. If I started at a position of 2, and then I went to the right 5, I'm at 7. If I went to the left 3, I'm at 4. And then if I went to the right 1, I'm at 5. So this would be 2 plus, the displacement is 3. That gives me x of 6 is 5. That means I'm furthest right at t equals 3 with a position x of 3 equals 7. Okay, so like now if we understand areas under velocity, we understand displacements. And we can use that to answer my questions. All right, show how you can calculate average velocity two different ways. One using the average rate of change in position, the other using average value expression with an interval. Okay, so we're talking about from 1 to 4 average velocity. So you could say, you know, reminding yourself that the slopes of position equal velocities. That means the slope of the secant, or the average rate of change of position, will give you the average velocity. You could say, okay, x of 4 minus x of 1 divided by 4 minus 1. That'd be the average velocity. You know from the fundamental theorem of calculus that if you have x of 4 minus 1, that's like an ending position minus a starting position, that's a displacement. You know that that is equivalent to the integral velocity, the areas under your velocity. This is displacement. This is your position form of finding displacement. This is kind of your area form of finding displacement. So all of a sudden, you could say, oh, that's the same as this to this of this divided by that. Okay, so these are equivalent. These both give you average velocities. Now, what's important is that an average of something, and we also talked about this in a non-kind of theoretical way, is like you can, you know, look at the area, which is almost in a sense like summing up all of the values of whatever you're looking at, and then divide it by kind of the interval. It's really kind of, this is a better way of introducing it, but just keep in mind this, that you need whatever you're trying to find the average of in your integral. You're finding kind of the sum of all of the values, which is kind of like the area divided by like the interval in which you're traveling over. This is not theoretical. This is more just kind of a decent way of understanding average. If you ask for average position, you will have to find the area under your position. Divide it by 3. Instead of dividing by 3, I'm going to multiply by 1 over 3 minus 0. And let's say I don't have a calculator. You would have to take the antiderivative. I get 1/4 t to the 4th minus t cubed. Find the change in that plus c, but we don't need it in this situation because we're finding the change. From 3 to 0, I'll use my calculator for this. I mean, I said no calculator, but then I'm telling you can use your calculator. So like 3 to the 4th divided by 4 minus 27. So it's 81/4 minus 27. 27/4 is 108/4. Also, subtract your initial position, which is 0. You don't have to worry about that. So 81 minus 108, just to do this quickly, is negative 27/4. So I got 1/3 negative 27/4, which is negative 9/4. Okay, now be careful. Now you're asked for the average velocity. What's very important is that you need, if you were going to do it the alternate way, I mean, I can show you two different ways. You could do just x of 2 minus x of 0 over 2 minus 0. Or let's say you have your calculator. You can find the area from 0 to 2 under your velocity graph, and then divide that by 2 minus 0, multiply that by 1/2. If this is position, velocity is 3t squared minus 6t. I'm going to just go ahead and show you the two ways to get the same answer. Let's say I have your calculator. So x of 2 is 8 minus 12, which is -4. X of 0 is 0. So I get an answer of -2. And then over here, watch how I can say, let's just go back to the nice looking mode. Integral from 0 to 2 of velocity, that's 3t squared minus 6t. 3t squared minus 6t. Divided that by 2. There you go. You know, it's because they're equivalent. But show you the two ways you can get your answer. Now, asking you for average velocity, they're giving you velocity. Well, since they give you velocity, might as well just do it using the integral. 1 over b minus a times the integral from 1 to 3 of velocity. Notice I could have the 1 over b minus a here, or I could have it down here. It does not matter. It's the same thing. I just like to write it to the side just so it's not super large. So I got 1/2. Let's say I don't have a calculator. I'll have to take the antiderivative, t cubed minus 3t squared plus c. I don't need it because I'm finding the change between 1 and 3. So I'll have 1/2, 8 minus, no, that's an 8, 27 minus, this is 27, minus 1 minus 3. So this is 1/2. This is -2. That's a +2. So that's 1. Okay. Just to confirm the answer, like you need to be able to do this with and without a calculator. 1/2 math 9, 1 to 3 of velocity. 3t squared minus 6t. 1. Okay, good. But now I ask you for the average position. Okay, so this is very important. Average position. To find the average position, you're going to have to find the integral or the area under your position function. Then multiply that by 1 over b minus a. Notice it's position. It's not the same thing as what we did here. You have to do a little bit of extra work, and you're going to have to find x of t, the full x of t. Well, I got to take the antiderivative of v. And I get t cubed minus 3t squared plus c. I am told that the initial position x of 0 equals 2. I need to use that to find c. C is 2. Here's x of t. T cubed minus 3t squared plus 2. Okay, now to finish this off, 1 over b minus a, integral from a to b of this, we'd have to calculate this. Just to save some time, I'm going to use my calculator. The setup is the more important part. The rest is the calculations part. 1 to 3 of t cubed minus 3t squared plus 2. -1. Okay. Okay, so that's average. Let's go to free response questions. You'll see you have a lot of calculator questions. We're going to do all of these questions. Okay. So here we go. It's a good review of everything. It's a calculator question. So great. We have our calculator ready. We're ready to answer every question that we have. This is good review for our tests. All of our free response questions are reviewed for a test. Part A, is the speed of the particle increasing or decreasing at t equals 5.5? Give a reason for your answer. I'm given an equation for a velocity, given an equation for acceleration. So if I just find my velocity at 5.5 and my acceleration at 5.5 and compare the signs, let's make sure we're in radian mode, we know speed is increasing or decreasing based on the signs of both velocity and acceleration. So I got 2 sine e to the 5.5 over 4 plus 1. So I get v of 5.5 is negative 0.453. So that means I'm traveling to the left. Let's find my acceleration at 5.5. I got 1/2 e to the 5.5 divided by 4. It's nice that they gave you the derivative. You could have found this using the chain rule. Cosine of e to the 5.5 divided by 4. And I get that A is also negative. Well, since V and A have the same signs or the same direction, and this is my explanation, this is my reasoning, this will give me my full credit for the question, speed is increasing. I'm speeding up going to the left. Part B, find the average velocity. Okay, since you aren't given the position function, you don't know how to take the antiderivative of v, you're going to have to use the alternate approach, which is to, and we're trying to find it from 0 to 6, which is to find like the sum of all of the velocity values and then divide it by the interval, or find the area under velocity. Multiply by 1 over 6. You have your calculator. Obviously, you're going to do this with your calculator because you don't know how to take the antiderivative of that. 1/6, math 9, integral from 0 to 6 of 2 sine e to the t over 4 plus 1. Okay, negative 0.08. Let me try to type that in correctly. 2 sine e to the t over 4 plus 1, radian mode. Okay, so negative 0.081. Part C, find the total distance. Distance, speed times time. You have your calculator. Sweet. Distance. Integral of your speeds times your time. Use an absolute value. Put your velocity inside the absolute value. Here's my speeds times my times. Area under my speed graph will give me, I don't think it's actually easy to do. Math 9, 0 to 6 of math num abs 2 sine e to the t over 4 plus 1. Oh, I did make a mistake up here. I need a close parentheses here, then a plus 1. All right, I'm going to go back. 12.573, whatever units that is in. They don't stress out about it. Let's go back to this. I messed up when I entered this in. I should have closed my parentheses around my sign here. second insert, close parentheses. Then I add the 1. Yeah. So this will give me a different answer. Yeah, 1.949. On average, I'm moving to the right. So be careful when you're doing these problems. Part D, particle changes direction exactly once. Find the position of the particle at that time. Okay, so changes direction. That's going to be when your velocity will equal 0 and changes sign. So we're going to graph velocity. So in my y equals, I'm going to graph 2 sine e to the t over 4, close parentheses, plus 1. And it changes from 0 to 6 once, so I'm going to adjust my window to 0, 6. And I see right there. Now I'm going to go ahead and also graph y equals 0, find this intersection. Now, since this time is not my final answer, I do not want to round this. So I did the work using my calculator. This number, I'm going to leave all the decimals in it because it's not my final answer. Now, I need to find my position at that time. Now, here's the deal. You can't take the antiderivative of velocity. I'm going to write that over here. So what you're going to have to do is use our calculator. Use what you have. You have an initial position. It kind of hides on you. We haven't used it yet in any of our questions until now. We know our initial position is 2. That's my position at time 0. My ending unknown position we equal a starting known position plus my displacement. We know displacement is area under your velocity curve. So we need to do this calculation. 2 plus integral from 0 to 5.1955223 of velocity 2 sine e to the x over 4 plus 1, close parentheses, plus 1. And this is my position at this time, 14.134. Okay, this is a very typical problem you are going to see on your test, part A, B, C, D. 9 points each, 9 points that you can earn. It's probably going to be like 2 points, 2 points, 2 points, maybe this is like 1, this is 2, but it'll be spread pretty evenly for this question. All right, I'll give you a graph of velocity. Okay, so here's the graph of velocity. Velocity at 0, 3, and 5. Okay, 0, 3, 5. Graph has horizontal tangents at 1 and at 4. Okay, thank you. The areas of the regions are 8, 3, and 2. So from 0 to 3, they say the area is 8. We know we're going to consider that negative 8. That means I'm moving to the left 8. And this is 3, and this is 2. But I'm going to consider that negative 2. Now, understanding the areas under velocities would be displacements. This means I'm moving left 8 from 0 to 3, and then I move right 3, and I move left 2. So writing that down just so we understand. Okay, part A. At time of 0, the particle's at x of negative 2. This is, again, this is sneaky. They're just fitting this in right here. But you gotta, We're going to have to remember that for the future. X of 0 is negative 2. Okay. Both the time and position of the particle and the particle is farthest to the left. Okay. Farthest left. That will be when our position, x of t, is a min. That'll be when x prime changes sign from negative to positive or at an endpoint. X prime is v. V's are negative, then positive, then negative. Now, the important part is the justification of your answers. So you got to kind of go through this rather than just say like, well, I know that I travel to the left 8, then right 3, then left 2. So I know my min is going to be at a position of negative 10. You got to go through this process. So 0, 3, 5, 6. Zero through 5, really. And it's negatives, positives, negatives. You're going to say your minimum position is either at x of 3 or x of 6. Because velocity is negative. Right before 3. And 6. Velocity is negative before 3, and velocity is, it's negative before 6. You just have to now compare your positions at time 3 and 6. Again, we don't have a position function. We have a velocity curve. So we're going to have to find it using our our unknown position equals a known position plus our displacement. I get negative 2 plus negative 8, which equals negative 10. And then I get x of 6 is x of 0 plus integral from 0 to 6 under v. This ends up being negative 2. This is negative 8 plus 3 is negative 5. Negative 6, negative 7, which is negative 9. So I would say when t equals 3, x of 3 equals negative 10 is the min. And I'd said by the candidates test. Probably to get full credit, you'd have to say position as min at a relative min when x prime changes from negative to positive or at endpoint. That will kind of be your justification. That's probably worth like 3 or 4 points. How many values of t is the particle at x equals negative 8? Explain your reasoning. I mean, we know x of 0 is negative 2. We know x of 3 is negative 10. We know x of 5 can be found. It'd be negative 10 plus 3. Negative 10 plus 3 is negative 7. And we know x of 6 is negative 9. So since these are like my interesting locations and my velocities are negative and positive and negative, I'm moving to the left. Then I'm moving to the right. Then I'm moving to the left. I can see I must pass through negative 8 1, 2, 3 times. X of t must equal negative 8 3 times. One time between 0 and 2, or 0 and 3. One time between 3 and 5. One time between 5 and 6. It's because velocity values are consistent in these intervals. So I must be traveling to the left from a position of negative 2 to a position of negative 10. I must pass through negative 8. I can say both because velocity values are consistent on those intervals, and I'll just call it on that. And I'm traveling to the right from -10 to -7. I have to pass through -8. Traveling to the left from -7 to -9, I have to pass through -8. And I don't want to say consistent. I want to say has consistent signs. Part C, speed of the particle increasing or decreasing from 2 to 3. So from 2 to 3, velocity is negative. However, the derivatives of velocity, which are acceleration, is positive. Speed is decreasing. Signs of V and A are opposite. Part D, during which time intervals is the acceleration of the particle negative? When V prime G equals A is negative, that's going to be from 0 to 1 and from 4 to 6. Why do I say 0 to 1 and 4 to 6? The slopes of V are negative here. Slopes of V are negative there. Hey. All right. I have a position graph. When is the particle furthest to the left? Justify your answer. Okay, so first to the left is an X a min. X will be a min at a relative min. That's when X prime changes sign from negatives to positive, or an endpoint. I'm going to find X prime. I got to use the product rule and the chain rule. So the derivative of the first times the second plus the derivative of the second times the first. So derivative of the first would be negative e to the negative t times the second plus the derivative of the second is cos t times the first. I'm going to graph that, set it equal to 0. So y equals negative e to the negative t sine t plus cos t e to the negative t. All right, now let's look at the values here. Looks like the values are positive and then negative, and like it looks like they stay negative and they'll be approaching 0. They never actually get to 0, and that should make sense. Maybe it makes sense. I could set this equal to 0, factor out and solve. Oh, I don't really want to do that right now. Let me just look a little bit further out. Yeah, we're close to 0, but we're not actually 0. See how like we're really, really close to 0. We're never going to get to 0. So it looks like we just have one intersection here. Second calc intersect. Watch this. Enter, enter, enter. It should go. Oh man, like it tells me that, but that's not actually it. It's just like close enough to 0. Oh, I got to do a little bit of work here. Oh, from 0 to 2 pi, thankfully. So 2 pi. Yeah, definitely negative. Oh, wait, it's positive. Oh, it's negative. Shoot, so there's 2 intersections. Watch. I know that there's 2 intersections. This is I should be doing some work here. But let's change our window, 0 to 2 pi. Let's adjust our y min, y max. That way I am there you go. You'd see negative values to positive values. I have another intersection right here. Let's adjust your window even more. I can go from like negative 0.5 to 0.5. I can find this answer. You know, I know I can find this answer. There's multiple answers here. Watch. Factor out the e to the negative t. I got negative sine t plus cosine t equals 0. This is a tricky question. When does this equal 0? When are sine and cosine going to be equal to each other? That's going to be at pi over 4 and 5 pi over 4. If you find your intersection, second calc, intersect, up over to this guy, enter, enter, enter. 0.785, that's pi over 4. Yep. Second calc, intersect. .926, 5 pi over 4. Okay, so a little bit more difficult than I thought. That's okay. X prime values from 0 to pi over 4 to 5 pi over 4. You could use decimals here. You have a calculator to use for this question. Oh, never mind. It's a no calculator question. Pretend like I did nothing about that. So it's a no calculator question. We have to solve this equation. Boom, we solved it. Remember, to do this, you would either say, okay, negative sine t plus cos t equals 0. You can add sine, you can divide by cosine, you'd end up with tangent equals 1. Checking sines, like I can plug in 0 because I know that the next location where this could possibly equal 0 would be at negative 3 pi over 4. So I can plug in 0. I get 1. E to the anything is going to be positive, so this is a positive. If I plug in pi over 2, this is positive. Sine of pi over 2 is 1, so this becomes a negative 1. This is 0, so this is a negative. And I'm going to assume, and safely assume it's a positive. So I'm furthest left either at x of 0 or x of 5 pi over 4. Those are my candidates. X of 0 because I end up going to the right. So I could say like x of 2 pi, not a candidate. Because x prime is positive. For t less than 2 pi, between 5 pi over 4 and 2 pi. Okay. X of 0, that would be e to the 0 times the sine of 0, which is 0. X of 5 pi over 4 would be e to the negative 5 pi over 4 times the sine of 5 pi over 4. Do you know what that is? No. You know it's a negative value? Because sine of 5 pi over 4 is negative. So I know t equals 5 pi over 4. The particle is furthest left by the candidates test. Part B, find a value of the constant a for which x of t satisfies the equation a, x double prime plus x equals 0. So like this is tricky. A x double prime plus x prime plus x equals 0. Seems tricky. It's actually not that bad. If we can find what x double prime is and what x prime is, we can plug it into this equation. Watch what happens. Already found x prime. X prime is negative e to the negative t sine t plus cos t e to the negative t. X already found is e to the negative t sine t. E to the negative t sine t. Okay, and now I just have to find x double prime. It might be large. You have to use the product rule for both of these, so it will be large. So I'll have positive e to the negative t sine t. This is the derivative of the first times the second, plus the derivative of the second times the first, negative e to the negative t. And plus, product rule for this, derivative of cosine is negative sine. Derivative of e to the negative t is negative e to the negative t. So the derivative of the first times the second plus the derivative of the second times the first. Okay, that is x double prime. So first of all, immediately with what I see here, I could cancel this, and it's gone. So some a times this, e to the negative t sine t plus cos t times e to the negative t. So I'll put a negative e. Plus negative sine t e to the t, so negative e to the t sine t, plus negative e to the negative t cos t. Some a times that plus cos t e to the negative t should equal 0. Great. Okay. One thing I noticed inside this, the e to the sine t's will go away. That gives me a times, look what I have, negative 2 of these e to the negative t cos t's plus cos t e to the negative t. For these to equal 0, let's write this so it looks nice, e to the negative t cos t. For these to equal 0, I need a negative 1. A has to equal 1/2. It's a tricky problem. You're probably not going to see something like this on your test. Last one. Calculator, thankfully. Find the acceleration at time t equals 2. Acceleration is equal to derivative of velocity, v prime of 2. I'm going to use math 8. They don't ask you why or how. Second quit, clear, math, take the derivative with respect to x of 1 minus tan inverse of e to the x at 2. Negative 0.132. Part B, speed increasing at t equals 2. Well, I should say a equals v prime. A of 2 equals v prime of 2, which equals negative 0.132. We know the acceleration is negative. A of 2 is negative. V of 2, let's find v of 2. So let's go 1 minus tan inverse of e to the second. Just plug in 2 into your velocity. All right. Is negative 0.436. That's negative. Speed is increasing. Why? Signs of v and a are the same. Part C. Find the time at which the particle reaches its highest point. Justify your answer. Highest point. Oh, so notice we're moving along the y-axis, so we're going up and down. So that's important. Highest point would be a max x. Max x will occur when x prime, which equals v, changes sign from positive to negative. So at a relative max or an endpoint. I assume that we're just going to change signs once because they didn't give us an end location. So I'm going to grab v, which is x prime. So greater than 0, I see it's positive, then it's negative. Second calc, intersect. I'm going to find that intersection, 0.443. So literally, since my velocity is positive until 0.443, negative after that, I must have a max x at t equals 0.443, because v is positive for t less than 0.443, which means I'm moving to the right, and then t is negative for t's greater than 0.443. That's got to be the absolute max. And then part D, last part. Find the position of the particle T2. This particle moving towards or away from the origin at T equals 2. I already know the velocity is negative. Let's find the position. Can't anti-derive V. So we're going to have to use our friend. An unknown position equals a known position. Watch what they gave you. At T equals 0, Y is negative 1. I'm using X. You can use Y, whatever. At T of 0, Y, the Y position is negative 1. And then plus an integral from 0 to 2 under my velocity. And that'll give me my answer. So I have negative 1 plus integral from 0 to 2 of my velocity, 1 minus tan inverse e to the x. My position is negative 1.360. So since position is negative and velocity is negative at t equals 2, particle is moving away from the origin. All right, these are the questions you need to be prepared for your test. Thank you.